Okay, we have here a problem. A small ball with mass m is suspended by a string with length L. Because the string sweeps out the surface of a cone, it is known as conical pendulum. Find the expression for V. So I have here pre-illustrated the problem to save some time for the drawing. So we have here a fixed end and there is a string. Okay, may length daw yan na L. Let us say that string has a length of L. So this string has a length of L and it is attached to a fixed end and to a small ball with a mass M. So we are asked to find for the expression for B. Now let us first analyze the problem and let's say solution. Take note that this ball is just moving horizontally. Okay? And in the vertical manner, this ball is in equilibrium, otherwise, aangat bababa yung bolang yan. So, vertically, it is in equilibrium. Kasi nga, kung hindi, you can just imagine na pag andar ng bolang pag ganyan, umaangat bumababa. Okay. So, in a vertical sense, this is in equilibrium, and in the horizontal motion, it is moving with a centripetal acceleration. So, yan yung ating key takeaways, ano? Now, if we try to analyze, if this is theta here, this is theta, the angle that it makes with the vertical, and this is t. This is our r. So that r is somewhat the force. So that will be the centripetal force going toward the center of the circle. So I decided to analyze this ball separately here. Of course, this ball will have a weight that is directed downward. And if this is the tension cord T and this is theta, it will have here its components. The vertical component will be T cosine theta and the horizontal component will be T sine theta because that is opposite. We will apply Newton's law of motion and say summation of forces. Summation of forces at y is equal to 0, no? Because that is in equilibrium. And then we say upward to be positive. Upward forces positive. What are the upward forces? This will have T cosine theta. That will be minus W, which is mg. Okay, and that is equal to 0. So if we are going to rewrite this equation, we will have T cosine of theta is equal to mg. If we sum up forces at x direction, then that is equal to ma, no? So that will be equal to the centripetal force ma. So what we'll have is t, okay, to the right positive, that will be equal to t sine theta, and that is equal to ma. So this is the centripetal force, and that is equal to ma, but mac, okay, centripetal acceleration. So let us try to simplify it further. T sine of theta is equal to centripetal acceleration has a formula b squared over r, that is equal to m b squared over r. Okay. So this is equation number 1 and this is equation number 2. Okay, so we are having two equations. Let us try to formulate an equation that will be having an expression for the velocity. So if we will divide 2 by equation 1, what will happen is t sine theta over t cosine of theta, that will be what? That will be sine over cosine tangent of theta. So tangent of theta is equal to sine over cosine, and that will be equal to mb squared, over r, and that will be over mg. M will cancelled out. Let us try to cancel out that m will cancel out, so what will be left is tangent theta is equal to b squared. Okay, b squared over gr. Okay, b squared over gr. Okay, so simplifying this further, we will have gr tangent of theta, but this is squared, so we have to take the square of the other side, or the both sides of the equations, and then we will have b on the other side. Okay, so that is gr tangent of theta is equal to b. Now if we want to simplify it further, what is actually r? This r here from this one is what? We say sine of theta is equal to the opposite side, which is r, over the hypotenuse side L. Therefore, r is equal to L sine of theta, coming from this triangle. So we are having this one. Therefore, if we are going to substitute this r here to simplify it further, so we can say that we have the square root of L sine theta, gawin natin blue, L sine of theta, and then gawin natin red yung G tangent of theta. Yan, is equal to V. So therefore, we have L sine theta times G tangent of theta is equal to B. Okay, so this is sine, no? Sine theta. This one is tangent theta. So there you have it. That's our solution. The key takeaways will be you treat this horizontal movement as a centripetal action, and then you just treat the vertical as in equilibrium, because there is no vertical motion, and then you apply Newton's second law, or Newton's law of motion, summation of forces y is equal to 0, and you will arrive at two equations. To manipulate that, we use our knowledge in trigonometry and come up with an expression that will lead us to the velocity. Okay, I hope this one will help. We have here another problem. A pack of mass 0.5 kilogram is attached to the end of a cord 1.5 meters long. The pack moves in a horizontal circle as shown in the figure. If the cord can withstand a maximum tension of 50 newtons, what is the maximum speed at which the pack can move before the cord breaks? Assume the string remains horizontal during the motion. Okay, we have illustrated here the problem. There is this string represented by this blue line here, and this is the pack. What is the pack? A puck is a disc made of vulcanized rubber that serves the same function in various games. So, yun yung mga honey puck, no? So, it's just a ball, just like a flat ball. And anong ibig sabihin? The puck moves in a horizontal circle. So, ang ating motion is horizontal circular motion. So, we can apply a uniform circular motion in this case. So, ang tinatanong sa atin, what is the maximum speed? So, velocity, maximum speed at which the puck can move. Now, given tayo nung tension na 50, so kailangan daw yung force natin na centripetal force must be equal to the tension in that rope para hindi mag-break yung ating cord. Okay? So that is the key takeaway or key analysis of that because we are given the maximum tension of this cord to be 50, then kailangan daw yung 15 yon hindi lalagpas yung ating centripetal force doon. So, we can say FC is equal to T. But what is FC? FC is equal to MA or MAC, no? MAC. So, FC is equal to T, T is equal to MAC, but what is AC? T is equal to MB squared over R, no? So, if we want to get B, so we will be having B is equal to, we cross multiply, R multiplied by the tension over M. But this is squared, so we have to subtract the square root of both sides, and that will be RT over M. So that is equal to, what is our R? R is equal to 1.5 meters. And what is our T? T is given to be 50 Newton. Multiply that by 50 Newtons. But what is Newton? Kilogram meter per second squared. Okay. Divide that by, what is the mass? The mass is 0.5 kilograms. 0.5 kilograms. Okay. And then we have to extract the square root. So kilogram will be cancelled out. Kilogram will be cancelled out. We will be having meter squared per second squared, and if we extract the square root, we will arrive at meter per. The answer will be in meter per second. Okay, because this one will become meter squared per second squared. So let us try to grab a calculator. So we are now ready to compute 1.5 times 50. That will be divided by 0.5, and we have to get the square root of this one. So square root, that will be 12.2474. So 12.2474. Okay, this will be your answer.